A lot of people have written code to do very critical things like create network connections or render movie files or hash files, lots of different things. And we can use their code. In this section, we're going to talk about importing libraries. And technically, they could be called libraries or modules or packages. There's some nuanced differences between the two. But the gist is somebody else has written some code, and we want to use that code to make our programs do powerful stuff without us having to write everything. So we will experiment with the import function. So let's open PowerShell, the interactive interpreter Python. I'm running PowerShell. I'm launching Python from PowerShell. Here's a line of code. It's going to fail, but we're going to run it anyway. Like if we want to work with dates, working with dates is actually quite tricky. There's a lot of weird use cases and weird edge cases, like, working with leap years and all that kind of stuff. So we want to use the code that somebody else wrote. For example, to get today's date, how do we do that? If I try to run datetime dot date dot today, it's going to fail. It's like, I don't know what you're talking about. Python's like, I have no idea what a date time thing is. Okay, fair enough. Python does actually know about dates and times, but we have to tell it that we want that feature enabled in our current program. So basically we do that with this line of code, import datetime, import datetime. So there's a Python file that is distributed with Python that has all the code to work with dates and times. And so that we're basically copying and pasting all of that code, making it available in our current program. Now that I told Python to import it, I have access to those features. Now I can run that same line of code I just ran previously that failed, datetime.date.today. And it tells me the current day and time. Yes, it is Halloween 2024 as I'm running this. So it is correct. It got the date and time correct. Or I just asked for the date. I didn't ask for the time here. It worked. So if I need to use dates in my program, I don't have to write code that checks the computer clock. I don't have to write code that, formats things as year, month, and day. Python is going to do that for me. I just have to import date time and then use those functions. I can also make specific dates if I want to. I could run datetime.date 2022/6/20, and it just printed that right out again. This is a date time object. So instead of strings or integers, it's a different data type. It's the date time data type. If we want to work with times, we could do that as well, looking at some of the other functions in there. There is another way to import these features, like maybe that date time package does a lot of stuff and we don't need everything from it, so we can just import just enough. So we could use a different syntax, like this example, from date time import date. And then we can use this code date.today, and it prints out the current date again. So the way I access this is a little bit different. I didn't have to type out datetime.date.today because I used this different syntax. I went into the datetime package and only imported date in that particular case. That gave me access to the word date here in my code without having to prefix it with datetime dot. A lot of this, when you're new to Python, this will help you read the code and understand what's happening when you're reading somebody else's code. Typically at the top of the file, you'll see a lot of import statements, and you'll see all the different code that is being incorporated into a single program by looking at those import statements. So let's take a look at another one, the OS. So if I import OS, OS is for operating system. So if I want to work with like users, folders, things on this computer, the operating system knows about those things. So this operating system package has all the code written to find that information for me. For example, I could run the code os.path, that's like a folder or directory on your computer. I'm going to check if something exists. Yes, a root directory does exist, but does something called home exist? False. So why would that be false here on, if I ran this on Linux, that would probably be true, but on Windows, there's no home path because Windows uses the C users directory. So this is one way that you could write your code to work on Linux or Windows by checking if certain paths exist. We can also see what is our working directory. os.getcwd, and I am in the C users administrator directory. Now one thing that's interesting here, why are there two slashes here? C:// users and / administrator. Here it's showing us the full path. It's using that first slash is escaping the second one. It's telling us that this is the slash character. So it's using the escape sequence. There are lots of other features. I'd recommend that you look at the documentation to see what could you do with that OS package. I don't expect you to be an expert in it just yet. Like if I open up this code, we can look at the official documentation. Learning how to read the documentation is really helpful. It can be somewhat dense and difficult to parse, but it's a skill. You can go through here. You can see it's pages and pages of information. But they're like, oh, there's something called os.name. That could be helpful. Like, is it Linux? Is it Windows? What kind of operating system am I working with? Tons of stuff. So they've done the hard work of making sure that this code will work properly. We just have to know how to use it in our programs. Another library which is useful, in my opinion, is the hashlib library. So if I import hashlib, we have access to different hash functions. So for example, if we want to calculate the SHA-256 hash of the word watermelon, we could do it with that line of code that I'll type, hashlib.SHA-256. We're going to run that function and pass it, instead of an F string, I'm going to use the letter B here. This will convert the word watermelon to its bytes, basically, the zeros and ones that make up that word. And then I want to produce the hex digest. So if I run that, if I typed everything correctly, I should see the hash, and I do. 256 bits. This should be 64 hexadecimal characters, so that's good. This could be useful, for example, if you wanted to create your own password cracking program. You might want to hash different values and see what those values are. Or if you're storing passwords, you would use a hash function, hopefully with salting, use a good algorithm to save those passwords rather than storing those passwords in clear text. So what does this hash lib do? One thing that you can do just to inspect it real quickly, you would pretty much only do this from the interactive interpreter. If you run dir and pass it the name of your library, dir hash lib, we can see we've got some dunder methods here, and we can also see the algorithms that it supports. So it supports MD5, SHA-256, SHA-3. That's great. It's already there. It's not as widely adopted. scrypt here is very similar to bcrypt, but instead of just chewing up CPU, scrypt will also chew up your RAM. So if that's a feature that you want, scrypt is good. Lots of good algorithms here that you could use depending on your use case. So if you're working for a client and they said, we need you to use this specific algorithm, you could check here to see if this library supports it. Of course, you could go to the official documentation. Also, I'd encourage you to check it out. There's lots of examples there. Let's take a look at scrypt, see how it's different. Here's some sample code that I developed. hashlib.scrypt b quote watermelon. So we're going to hash the same word as before, but we're going to have to add some salt. It's good to add salt to your password hashes. Salt equals, we're going to use the operating system library now. We're going to say operating system urandom, give us some random data. Give us that much data. N equals 4, R equals 8, P equals 1. Oh gosh, does that look good? Not terribly good. It is valid, it is correct. If I hit the up arrow key, I can run that again. I should get a different value each time because it's generating random salt. But that data, they're all valid hashes. What does all of this stuff mean? I'd encourage you, go to the documentation and see if you can figure out, like, what is N of 4? What is R of 8? What is P of 1? As an alternative, you could throw that into ChatGPT and say, what does this code actually do? It's usually pretty good at providing a helpful explanation. All right, here is some sample code and a challenge. Looking at this code right here that I'm selecting, let's just read it. We import the hash lib. Okay, so we want to do some hashing. There's a password with the variable with the value watermelon. We store the hash in a variable called SHA. So we do hashlib SHA-256 bytes password. This is an ASCII encoded word. Oh, that's fine. The output is the hex digest, so that's a little bit more human readable, which is good. And then we're printing out using F strings both the password and the output. So see if you can do this. I'm going to walk through it, but pause the video. See if you can complete this exercise. I'm going to create a new file called hashem.py because we're going to hash them. So copy, then modify this code. All right, I will follow the instructions. I will copy this code and I will paste it over here in Visual Studio Code. Copying and pasting can be dangerous, but this code's safe, I assure you. It's not going to do anything bad on your computer. All right, now what should I do to change this code? Change the name of the password variable to passwords. So I'm just going to add an S there, passwords, plural. Set the value of the passwords variable to a list of passwords. Okay, so I need to change my data type. If I want to use a list, I'm going to use those square brackets. So I'll do watermelon, orange, and pass123. Real bad password, but there it is. Put that square bracket at the end of there. I don't see any syntax errors there yet. I do see some squiggly lines under password on line 3 and password on line 5 because I've never defined the variable password at this point. I defined passwords, plural. So this is saying I have no idea what you're talking about. Password is not defined. Yeah, we'll fix that. We'll get there. Loop through each password in passwords. I know how to do a loop. For password in passwords, plural, colon. And now I'm going to indent each of these following lines so that for each iteration of the loop, this will evaluate one password in the list at a time. So every time it goes through this loop, we're going to create a new value for the SHA variable. We'll create a new value for the output variable, and we'll print out the password and the output. All right, should this code work? Fingers crossed. Here we go. Play. Yeah, seemed to work okay. So what do I see here in the output? I see watermelon, colon, then the hash of watermelon. I see orange, colon, and then the value of the SHA-256 hash of the word orange, and then the same with pass 1, 2, 3. I see that output right there. So already we're starting to do some good stuff. This gets us a little bit closer to writing a custom password cracker, because now we can loop through. Essentially what we did was we created a small dictionary here. Our passwords list is a password dictionary. It's not a very big dictionary, only 3 words in this particular password dictionary. But then we're looping through and creating a hash of each of those words in the dictionary. We have no targets yet. We have no hashes that we discovered from a data breach or a hypothetical data breach, but we're getting closer, building that skill set to be able to create a custom password cracker. All right, so key takeaways here. We're going to be looking for imports, especially as we're reading other people's code at the top of those files. We're going to see what are they importing? What features are they bringing into their code that they are leveraging? And then we need to make sure that we're accessing those features appropriately. We've got the right syntax. So to use that hash lib here in this example, I'm using hashlib.sha256 because that's what the documentation told me to use. And I provided that sample code here that I know works properly. So I didn't have to figure out how that algorithm works. I just have to figure out how to use the algorithm that somebody else developed for us.